Hello everyone and welcome to TalentSprint. In this session we'll learn about quadrilaterals, which is a part of geometry. Now as you all must be aware, a quadrilateral is a closed figure which is bounded by four straight lines. In simple words, a quadrilateral is a four-sided plane figure which has got four internal angles, four sides and four internal angles. And the sum of all its internal angles is always 360 degrees. Now based on the shape, there can be different types of quadrilaterals. For example, parallelogram, rhombus, trapezium, rectangle, square, kite or arrowhead, which is also known as delta, are some of the different types of quadrilaterals based on the shape and its various properties. Now of all these different quadrilaterals, the most important ones are parallelogram, a rhombus, rectangle, square and trapezium. And hence we'll limit our discussion to only these type of quadrilaterals. And among all these, the most important one in my view is a parallelogram, because all the other important quadrilaterals like rhombus, square, rectangle and trapezium can be treated as special cases of a parallelogram. Hence we'll start our discussion with the first quadrilateral, that's a parallelogram. Understand that for you to answer questions based on quadrilaterals, you must know all the important properties for each of these different quadrilaterals. So all we are going to discuss here is about the properties of different types of quadrilaterals, and we shall start with parallelogram. Like this is the basic one and all the others can be taken as special cases of a parallelogram. So let's understand what a parallelogram is. As you can see here, ABCD is a parallelogram, right? The four-sided figure ABCD is a parallelogram. Now what is special about a parallelogram? Well, this is a quadrilateral where the opposite sides are parallel and equal, right? A parallelogram is the one where the opposite sides are parallel. Now as you can see, the name itself has the word parallel there, right? The root word parallel. So the opposite sides here are parallel, which means they'll never meet, right? Opposite sides are parallel and they are equal. Alright, so we can say that AB is equal to CD, right? Opposite sides are equal, and the other pair of opposite sides is also equal. AD is equal to BC, and also the opposite sides are parallel. So we can say AB is parallel to CD and AD is parallel to BC. So this basically defines a parallelogram. The opposite sides are parallel and equal. Such a quadrilateral can be treated as a parallelogram. Now let us look at the different properties of a parallelogram, right? That's about the definition here, but what are different properties? Now one important point that we have already discussed is that sum of the internal angles is 360 degrees, right? There are four angles here: angle A, angle B, angle C and angle D, and sum of all these four angles is equal to 360 degrees. Well, this is true in every quadrilateral, right? Any four-sided figure will have the sum of its internal angles as 360. So nothing special about that point, right? But let us now discuss points which are specific to a parallelogram, right? So that's about the definition here. Now let's look at the properties. The first important point here is that the sum of any two adjacent angles in a parallelogram will be equal to 180 degrees. You take any two adjacent angles, right? What are adjacent angles here? Angle A and angle B, or B and C, C and D, and D and A, right? Adjacent angles. What are opposite angles? Angle A and angle C, and angle B and angle D. So the point that I'm trying to make here is that sum of any two adjacent angles is always 180 degrees in case of a parallelogram, right? So how do we represent that? We can say angle A plus angle B will be equal to angle B plus angle C. Angle B plus angle C will be equal to angle C plus angle D, and this will be equal to angle D plus angle A, and all these are equal to 180 degrees. So adjacent angles, all these are adjacent angles, and sum of the adjacent angles is always 180 degrees. Alright, this is very basic. I mean, if you refer our discussion in triangles, where we have started about parallel lines, right? Pair of lines, parallel lines and a transversal. Based on those properties, you will realize that yes, angle A and angle B will be equal to 180 degrees. The sum of those two angles will be equal to 180 degrees, right? Because if you make or if you club these two angles, it becomes a straight angle. Straight angle is 180 degrees. You understand? See, these two lines are parallel. As we have discussed, AD is parallel to BC. So this side of the angle A, right, the internal angle A will be equal to the exterior angle of B, right? If I extend this line, let's say, right, what is this angle? This is nothing but angle A. So if we see, if this is angle A and the interior angle is angle B, angle A plus angle B makes a straight angle, 180 degrees. And the same holds true for any pair of adjacent angles. So that is the reason we come to a conclusion that the pair of adjacent angles will add up to 180 degrees, right? And from this point, if you observe, if you take the first two expressions there. Angle A plus angle B equals to angle B plus angle C. Only look at these two. Angle B and angle B gets cancelled. So what are we left with? Angle A is equal to angle C. Angle A is equal to angle C, which means the opposite angles are equal. Let's look at the other set here, right? If you see angle B plus angle C is equal to angle C plus angle D. Now C and C gets cancelled. So what do we have? Angle B is equal to angle D. Angle B is equal to angle D. And again, if you consider these two, D and D gets cancelled, C is equal to A, which we have already derived, right? A is equal to C or C equals to A. Again, if we take A plus B equals to D plus A and A gets cancelled, we will get B equals to D. B equals to D. So clearly we can conclude that in case of a parallelogram, the opposite angles are equal, right? Whatever be the angle, they are always equal. So angle A would be equal to angle C. And what's the other one? Angle B is equal to angle D. Now, what will be the numerical value here? We cannot, discuss or talk about that, because it can be anything, right? If this is, let's say, 120, or this is not 120. I mean, that's an, that's an acute angle. I mean, when you look at it, it looks like an acute angle. But whatever be the value, let's say if this is 80 degrees, this also would be 80 degrees. And if this is 80, this would be 100, because the adjacent angle should add up to 180 degrees. So these are important properties with respect to the angles. So adjacent angles will add up to 180, opposite angles are equal. Angle B is equal to angle D. Now let us talk about the diagonals, right? You know what diagonals are. The line joining the two opposite vertices are diagonals. So here we have got two diagonals. AC is one diagonal and BD is the other diagonal, right? And if you observe, these two diagonals intersect at the point O, right? Point O is the point of intersection of the two diagonals here. Now in case of a parallelogram, the diagonals are not equal, right? AC is not equal to BD. AC is not equal to BD. So the diagonal AC is not equal to BD, right? I mean, when we discuss about the other quadrilaterals, right? Rectangle, square and rhombus, we'll talk about diagonals always. In which cases the diagonals are equal and in which cases the diagonals are not equal. So in case of a parallelogram, the diagonals are not equal, but they bisect each other, right? The two diagonals bisect each other. That means if you look at this point of intersection O, this point is bisecting the diagonal AC and it is also bisecting the diagonal BD. Now what do you mean by bisection here? It will divide it into two equal halves. So we can say AO is equal to OC, right? AO is equal to OC and BO equals to OD. So the point is, in case of a parallelogram, the diagonals are not equal, but they bisect each other, right? All are important properties. You just need to remember and understand these properties so that you can answer the questions easily, right? Based on any of these properties, we'll try and solve the questions given on parallelogram. And now the last point, right? The last point, which is again a very important property with respect to parallelograms. And this is that the sum of the squares of diagonals is equal to the sum of the squares of all the four sides. The sum of the squares of diagonals is equal to the sum of the squares of four sides, right? For example, I mean, if you look at this figure here, sum of the squares of diagonals. What are the diagonals? AC and BD. So sum of the squares of diagonals. So AC square plus BD square will be equal to the sum of the squares of all the four sides. So this will be equal to AB square plus BC square plus CD square plus DA square plus DA square. Are you able to follow? And we have already learned that AB is equal to CD and BC equals to DA. BC equals to DA. So we can say AB square plus CD square is equal to 2AB square. Both of them are equal. Opposite sides are equal, right? And similarly, BC square equals to DA square. So we can say BC square plus DA square equals to 2BC square or 2DA square, right? So we can also conclude this as AC square plus BD square equals to 2 times of AB square plus CD square can be taken as 2 times of AB square, and BC square plus AD square or DA square can be taken as 2 times of BC square. Yes or no? So that's a very important conclusion or a property with respect to parallelograms, right? Nothing but the sum of the squares of diagonals is equal to the sum of the squares of all the four sides. All right. So that's about the important properties of a parallelogram. And let us not get into mensuration part of a parallelogram, right? For example, area of a parallelogram or the perimeter of a parallelogram. All these have been covered in the mensuration topic, right? And we have a list of formulae. It's all about learning the formula there. For example, let's say if this side is AB, this length is A, the opposite will also be A. Yes or no? And if this is B, the opposite is also B. Alright, so based on these four sides, I mean, you know what a perimeter is. Perimeter is the length of the boundary. So you can say A plus B plus A plus B. So perimeter can be taken as 2 times of A plus B. When it comes to the area of a parallelogram, area of a parallelogram is nothing but the product of two adjacent sides into the angle between them, sine of the angle between them. So area of this parallelogram can be taken as AB into sine of angle B, right? Or this AB into sine of angle A, right? Or in general, for any quadrilateral, we can say that area is the base into height, base into height. For example, for this parallelogram, the height is h. Let's say the height of the parallelogram is h, right? Height is the vertical distance between the two parallel sides, right? So area can simply be taken as the base into height. Base in this case is A into the h. Height h will give you the area. So in simple words, we can say area is equal to A into h. And perimeter can be taken as A plus B plus A plus B. So 2 times of A plus B. However, like I've mentioned earlier, these are points relevant to mensuration, not related to geometry, right? With respect to geometry, we should know all the important properties based on angles, sides, and diagonals, etc. Right? So that's about a parallelogram. Now, 2 more important points here. Well, this is according to, this is in relation to rectangle and rhombus. But let me just mention those 2 points. Again, when we discuss about rectangle and rhombus, we'll bring it so that you can understand it easily. Any parallelogram which is inscribed in a circle will be a rectangle. I've already mentioned that rectangle, rhombus, square, trapezium, all these are special cases of a parallelogram. So one special case is the rectangle, right? So if you can inscribe a parallelogram inside a circle, right? If all the 4 vertices of the parallelogram lie on the circumference of the circle, then that parallelogram is nothing but a rectangle. And if it can be circumscribed around a circle, right? If you can draw a circle which touches all the 4 sides of the parallelogram, right? Circle is inside, touching all the 4 sides, then that parallelogram becomes a rhombus. However, when we discuss about rhombus and rectangle, it will bring in more clarity. But just remember, right? It can be given as a simple question in the exam. A parallelogram inscribed in a circle is rectangle or rhombus or square or trapezium or none of these, let's say. So what's your angle? What's your answer? Answer is rectangle, right? If parallelogram is inside the circle, touching all the 4 points touching the circle, circumference of the circle, then it is a rectangle. If the circle is inside the parallelogram, touching all the 4 sides, then it is a rhombus. Then such a parallelogram is called a rhombus. So that's about all the important properties of parallelogram.